Hello, by the end of today's video, you should be able to graph an equation written in slope-intercept form on a coordinate plane. For today's notes, you're going to need the sheet of paper that I gave you, and then we are going to tape this or glue this onto page 17 in your notebook. Because when you're graphing, you need a coordinate plane, and it's best if you use one that actually has measured little boxes. I know you can kind of sketch one out in your notebook, but that's not the best way to do it. We're going to look at a few examples, and I tried to vary the equations that we're going to be using so that you can see a variety of different equations. The first one we're going to graph, and I'm going to write them up at the top, is y equals 3 halves, or 3 over 2 times x, minus 2. Now, I always make sure that my equation is written in slope-intercept form. So y equals mx plus b. So the m value is going to be 3 over 2. That's a rise of 3 and a run of 2. And my y-intercept is negative 2. I'm going to start there with my y-intercept. The y-intercept, remember, is where this line is going to cross the y-axis. And it's at negative 2. So negative 2, 1, 2, is right here. So this is going to be my starting spot. I know that this point is on the line. And I know that my slope has a rise of 3 and a run of 2. So a rise of 3, 1, 2, 3, and a run of 2, 1, 2. So I know that this is another point on my line. Now, 2 points determine a line. However, I'm going to put a few more. In fact, I'm going to fit as many as I possibly can on this graph, because connecting more points with a straight edge will get me a closer approximation to where this line is. So up, rise of 1, 2, 3, over 1, 2. So this is another point, 1, 2, 3, 1, 2. And now I've run out of space. However, I can go down here. Now, to do this, I need to go down 3 and back 2. Down 3 and back 2. Because remember, a negative 3 divided by a negative 2 would also be 3 over 2. And now I can take my straight edge and connect these points. And this is a graph of that line. Let's take a look at another example. This one is going to be y equals negative 2x plus 3. So once again, let's look at our slope, which is going to be negative 2. Now I like to put the 1 underneath it because that's the rise over the run. And my b value is going to be 3. So let's start with this point because we know that this point is going to be 0, 3. And I'll put a point there. Now, my slope is going to be negative, so instead of going this way, I know it's going to be going that way. And it's going to have a rise of negative 2, 1, 2, and a run of 1. So there's my point. Negative 2, run of 1, down 2, over 1, down 2, over 1, down 2, over 1. Same way I can go up 2, back 1, up 2, back 1. On this line. Let's try 2 more since we have space for it. We're going to do the equation y equals negative 1 half x minus 1. So my slope is going to be negative 1 half, 1 over 2, and my y-intercept is going to be negative 1. Once again, we're going to start with the y-intercept of negative 1. And now my slope of negative 1 half. So rise of negative 1 and run of 2. Down 1, over 2, down 1, over 2. Or up 1, back 2. Points, and there we have it. This is a line of y equals negative 1 half x minus 1. So basically we can choose any x value to put into here, and then we will get the y value. So if we put 1 in for x, we would get a y value that puts that point right there. So we would get a y value of negative 1 point. So one more, y equals 3x. So in this case, our slope is going to be 3. And remember, I like to write change in y over change in x as slope. So I like to have the rise over the run. So I make it a fraction, 3 over 1. And, oh, there is no b. Well, that's because this is proportional. Look, it's written in the form of y equals kx. Remember, proportional relationships go through the origin, so our b is 0. Now, you could put plus 0 there, the y, right? This is more writing. So you just leave it off, and that clues you into, yes, it goes through the origin, because b equals 0, so when x equals 0, y equals 0, which lets us know that our y-intercept is right there. We still need to plot the slope. So a rise of 3 and a run of 1. So rise of 3, 1, 2, 3, run of 1. Rise of 3, run of 1. Oh, I can't fit the next one on, that's okay. Or down 3, back 1, down 3, back 1. Now, you could, with this, when you were graphing, if you're given a equation in slope-intercept form and you want to make the xy chart where you put x over here and y here, and then you choose some x values like 0, 1, and 2 and find out what their y's are and then plot those, absolutely, you can do that. However, if it's in slope-intercept form, there's a much quicker way to do it. You know the intercept and you know the slope, so you can just graph it from there. But either way of doing it, whether you plug 0 in for x and then figure out what y is, then plug 1 in for x and figure out what y is, or 2 in for x and then figure out what y is, plot those points, and then connect them, both will get you the same exact answer. Thank you.